Hi guys, there was a question from section 4.3, section 4.3 assessment B, and the problem is number 8. Let me see if I can explain it. So the first part, before actually I explain this, they're talking about the GCD and LCM. So let me first tell you the notation we're going to use here. So the first part, A, asks the question that if A and B are two different primes, so A and B are two different primes, he wants to know what is the GCD of A and B. So we want to find the GCD of A and B. Okay, so let me first remind you, I'm sure you read the section. The GCD stands for greatest common divisor. By the way, the divisor is also the same thing as factor. So some people think of this as the greatest common factor. So I think if you think of it like that, it makes a little bit more sense. So the greatest common factor. So when you have two natural numbers or whole numbers, you want to know what is the biggest factor they have in common, right? For example, 4 and 2, between 4 and 2, the greatest common factor is 2. Between, let's say, 12 and 3, or let's say 12 and 8, their biggest common factor is 4, right? Because 4 is the biggest factor they both have in common. So that's what GCD stands for. Now, if the two numbers are prime, oh, by the way, then I'm sure you saw the notation that, so if we write A and then vertical line B, that basically means that A divides B. A divides B. Okay, so that's what that notation means. So for example, just a side example, we can say 2 and then vertical line 12. Now why? Because 2 obviously divides 12. In other words, 2 is a factor of 12. So divisor means the same thing as factor. So 2 is divides 12, which means same thing as 2 is a factor of 12. And so we write that as 2 vertical line 12. So if you want to say A divides B, you write A and then a vertical line B, okay? Now if the two numbers are prime, what's the biggest factor they have? Well, remember, definition of a prime is prime only divides itself on 1. So if there are two different primes, their biggest factor they have in common has to be 1. Because remember, a prime number cannot have any other factor other than 1 on itself, okay? So that should answer your part A. Now part B, let me see if I can squeeze part B under here. It says, what is the relationship between A and B if, so this time you're given the condition that the greatest common divisor, again, don't forget the same thing as greatest common factor of A and B is A. So in other words, he wants to know what can we say about the relationship between A and B if the greatest common divisor of A and B is A. So which means, of course, that in this case, A must divide B, right? In other words, A must be a factor of B for that greatest common divisor to be A itself. So this means A, don't forget the notation, A and then vertical line B, which means A divides B. So anytime the greatest common factor of A and B is the number A, that implies that A must be divisible, A divides B. For example, if you want to find the GCD, let's say of 2 and 12, what is that going to be? Well, remember, since 2 divides 12, the greatest common factor, of course, would be 2. And that means that 2 must divide 12. Otherwise, 2 cannot be a greatest common factor or divisor, okay? So that's basically what that means. So last part, actually he talked about the LCM. You might remember something called LCD. Now, LCD is the same thing as LCM, except, of course, we only use LCD when we're dealing with denominators, right? I'm sure in later chapter, when we deal with adding fractions and things like that, we will just talk about LCD instead of LCM, but it's the same concept. So in part number 8, part C, it says, what is the relationship between A and B if the LCM, the least common, this is short for least common multiple, which basically means the smallest number that divides both of your numbers, okay? Now, usually the word least kind of confuses students because when you have two numbers, most of the time the LCM will be bigger than both of them, or at least the biggest one. So don't let the word least bother you, because that least means the smallest that has actually both of those numbers as a factor. So usually it's bigger than the numbers themselves, or at least the same as the biggest one. So this time we know the LCM of A and B, of course, happen to be A. So in this case, the question is, if the least common multiple of A and B is A, what can we say about the ratio between A and B? So this time, the situation is flipped, which means that actually B must be a factor of A, right? Otherwise, A cannot be the biggest number, smallest number that divides both numbers, right? So if it divides B, which means, if the answer is B, which means B also must divide A. So let me give you a quick example. Let me say, for example, just to kind of give you a number example, let's suppose we know, and this is we know, of course, because LCM, by definition, LCM of, let's say, number 12 and number 2 is what? What's the least common multiple? In other words, what's the smallest number that divides both? Well, we know, of course, 2 divides 12, but also 12 divides 12. So in this case, the LCM would be, of course, number 12, because that's the smallest number that divides both, right? So what does that mean? Of course, in this case, that means, of course, that the B, the number 2 must be itself, must divide 12. Otherwise, number 12 would not be their least common multiple between the two numbers, right? So this is an example, kind of a number example of this phenomena here, right? So anytime LCM of two numbers, A and B, is the first number, that means the second number must divide the first number. Just like in this case, LCM of these two numbers is the first number, which means the second number must be divisible or must divide the first number, okay? I hope that helps.